Okay, so everybody, so the first thing I want to ask you is, what does the word between mean? Lots of times when I say, what does between mean, the first thing people say is in the middle of. And where in the middle of could be between, for instance, if I put a point here and a point here and a point here, you would say that the blue point is between the red points. But it doesn't have to be in the middle. It could be in the middle of, but it doesn't have to be. Because even though I move this point over here, it's still between the two red points. Okay? So the word between, when you see that, means that one point falls in line with two other points, not outside those points, but somewhere between them. But it does not necessarily mean it is exactly in the middle of those 2 points. So I'm going to now attach these points with a segment, like such, okay? And I'm going to label this with the L being the point that is between the M and the N. Okay, now I'm going to be asked to add some information to this segment. So the information we're going to add, and actually I made a little mistake here by not putting my segments above my NL and my LM and my NL over here. We're going to, oh, you know what, there's actually a typo there too, but hold on a second. So let's go ahead and let's add this information to the segment. So I want to call NL, and actually now that I look at this, it doesn't make a lot of sense for NL over here to be 5x if LM is 3x. Obviously 5x is bigger than 3x, so I'm going to adjust my picture a little bit. I'm just going to move this point over here. Whoops, I don't want to move the line. If it'll let me. There we go. I'm going to move my point over here. So point L is in between M and N, and now I'm labeling those. ML is going to be 3x. Ln is going to be 5x, and I have a little typo here that I'm going to fix. I actually want Ln, I don't want Ln to be 15. Okay, sorry about that. I had to grab the guided notes that I had printed off for you. For some reason it was totally different here. So what your guided notes will say is that Mn is equal to 16. So now that I know that NL I have labeled as 5x, LM I have labeled as 3x, and Mn is equal to 16. I'm now responsible for making an equation in order to solve for x. Well, a generic equation that I could make regardless of what the values were is I could say, and this is something that comes sort of difficult for students to understand. If I'm going to take this segment here, that is segment ML. Whoops, why did it not let me do that? Oh, that's my highlighter doing that for me so graciously. ML. And if I add ML to this segment, which is LN, that's going to leave me with the whole segment. Piece plus piece equals whole. So that's going to leave me with MN. Okay? Piece plus piece equals whole. So now when I look at this and I say, okay, well, if part of this, let me get the right pen color here. If part of this is 3x and part of it is 5x, and from here all the way to here the whole thing is equal to 16, then the equation that I want to use in order to solve for x would be to take that 3x added to the 5x, that's piece plus piece equals whole. That's ML plus LN equals mn. And now I just have myself a two-step equation. Let's go back to Algebra 1 class. If I combine a 3x and a 5x, that gives me an 8x. Combining like terms. On the same side of the equation, I combine like terms. To solve for x, I'm going to divide both sides by 2, and I'm left with x, not by 2, by 8, sorry. And I'm going to be left with x equals 2. Awesome. We found x equals 2. Well, what if they then say, well, what's the length of ln? I'm going to go back up here. ln is equal to 3 times x. I now know that x is 2. I'm going to take this 2 and drop it right in there in place of the x. It's a substitution. So ln is the same thing as 3 times 2. So lm is a length of 6. Okay? So let's try this one real quick. S falls between D and F. Here's D, here's F, S falls somewhere in between. Okay? Segment, point, point, point. It's not exactly in the middle, but it's somewhere between those. Let's add to the picture that ds is equal to 6x minus 5. SF is equal to 2x plus 3. And df, which is the whole thing from here to here, is a length of 30. Not 36, 30. 30. So now we got to make the equation. Well, the generic equation is going to be ds plus sf equals df. That's piece plus piece equals whole thing. So if we just kind of fill the pieces in here, we have 6x minus 5 plus 2x plus 3 equals 30. Maybe you may want to pause this and take a minute to go ahead and solve this. I'm going to continue. I'm going to combine like terms. My like terms here are going to be a 6x and a plus 2x. Those are on the same side of the equation. And they're like terms because they both have an x. The other like terms I have are a negative 5 and a positive 3, so I'm going to combine those as well. Same side of the equation, I'm allowed to combine. 6x plus 2x is 8x. Negative 5 plus 3 is negative 2. Okay, I have a two-step equation here. Whoops, I didn't want to move that whole thing down. Two-step equation here. Add 2 to both sides. 8x equals 32. Divide both sides by 8. X equals 4. If I want to find the length of SF, I'm just taking this 4 and I'm putting it back in right here. So I have 2 times 4 plus 3. That's going to give me the length of SF. So 8 plus 3, which is 11. SF is equal to 11.